This is a typical ideal gas law problem. Pressure in the problem is in atmospheres, volume will always be in liters, N, that's the number of moles, R, let's talk about that in a minute, and temperature is always going to be in Kelvin. So what I can do is look at the problem. I see that pressure is 1.3 atmospheres. We're solving for volume, and that equals the 4 moles times R, and I'm going to use the R that you use when you have pressure in atmospheres. And then temperature in Kelvin, we have 298. So we have the problem set up. Now we just need to get volume by itself. What we can do is divide each side of the equation by 1.3 atm, and that'll give us volume by itself. So I've put 1.3 atm underneath each side of the equation, and now I can cancel some things out. So this is gone. And now if I look at my units, I have moles here and moles here. They cancel out. I've got liters. I've got atm here, and Kelvin here, and Kelvin here. That's going to leave us with liters. So if we multiply the top of the equation, 4 times 0.0820 liters times 298, and divide that by 1.3, we'll end up with our volume. People are often intimidated by R and all of those units, so let's talk about that for a moment. So R is useful because it helps us cancel units out, and it gives us an answer that makes sense. To find R, we'll look at the units for pressure that we find in the problem, and then we'll just match those to the correct value for R. So if we have atmospheres, we'll use this value for R. If we have kPa, this value, and then for millimeters of mercury, we'll use this value. The key is we're finding the units from the problem and making sure that the value for R matches those units for pressure. So pause and try this problem. So we have our equation, PV equals nRT, sometimes called Pivnert, and here I've filled everything in except for R. When I look at the problem, I can see that I have 50 atmospheres for my pressure. That means I'm going to need to use the value for R that has atmospheres in the units, and that's this one right here. To simplify, I'm not going to use the units right now, so I'm just going to put the number in the equation. Looks kind of lonely all by itself there. Now to solve and get N by itself, I'll just divide both sides by 0.820 times 333 Kelvin. So these terms cancel out, and we're left with N by itself. We take 50 times 25 and divide that quantity by the 0.820 times the 333. That would give us 4.6 moles, which would equal N. It's best to include the units for R in your calculations so everything cancels out and you know you have the correct final units. At the same time, some people don't do that. So pause and set this problem up and then come back. So here we don't know the pressure, that's what we're trying to find, and we're trying to find it in kPa. That's important. We know the volume's 20 liters. Moles, we have 3 moles. And then for R, we'll go back to our kPa and choose an R value that has kPa in the units, and that's the 8.314 value. And then for temperature, we have a bit of a problem here. We know that temperature is in Kelvin, but the problem gives us 25 degrees Celsius. So Kelvin equals degrees Celsius plus 273. So we'll put 25 in for the degrees Celsius, and that'll give us 298 as our temperature in Kelvin. And we can substitute that in the problem. So we divide each side by 20 liters, and then cancel everything out. Then we can multiply the top of the equation there and divide by 20, and that'll give us pressure in kilopascals. And we have our final answer. Let's do one last problem. When you look at this problem, it doesn't seem like you have much information. But the STP, standard temperature and pressure, gives you values for temperature and pressure. So standard temperature will always be 273 Kelvin, and standard pressure will be 1 atmosphere. So pause and use those values for standard temperature and pressure to solve this problem. So we have 1 atmosphere, we're looking for volume, we have 8.2 moles, and since we're using atmospheres, we'll use the 0.820 value for R, and then the temperature, standard temperature, is 273. When I do the math, I end up with a volume of 1835.6 liters. So the key to solving these problems, look at the units of pressure to figure out which R to use. Always work in Kelvin. If you have Celsius, you need to add 273 to convert to Kelvin, and practice. The more practice you have, the better you'll get at this. This is Dr. B, and thanks for watching.